Hey, I'm Daniel Krashin, and I'm gonna go over a simple economic model of a battery storage facility in the face of uncertain price distribution. So you can see here the gray line, which shows what would this facility return last year. And this is based on a real energy price data from the Chicago area. And what I'm going to do now, I'm going to load from ChanceCalc a zip library that will generate instantaneously thousands of possible outcomes for the future year. So here in ChanceCalc, and here we go. Now we instantaneously generated thousands of possible outcomes that are showed as trials. And you can see here that every time that I try new trials, the blue line moves because the blue line is a possible outcome for the future year. And in row 10, you can see the trial revenue that changes according to the blue line. The average does not change because the average captures the average of all the thousands of trials that our library loaded and generated. Moreover, we can even see the chances of generating a particular revenue. So here we can see the chance of generating over $800,000 is 41%. But what if we wanted to see the chances of generating over $840,000? It is only 15%. Also, we can see the different percentiles. So now in the blue bar chart, you can see the 10 percentiles revenue and the 90th percentile revenue. But what if we wanted to see the 28th percentile and the 80th percentile? And we can really do it over and over again, also in much more complex models. But this is not the real world, because in the real world, there are many parameters that we need to take into account. Most importantly is the location, due to the different energy prices and incentives across countries, states, cities, and even between transmission lines and public hubs. Next is our battery. Different battery technologies and materials will impact the battery efficiency and lifespan. The efficiency can be determined by the power losses during the storage or during the AC to DC conversions and vice versa. And for the lifespan, some batteries will start to degrade within 5 years and some in 10. The intuitive choice will be the long-term batteries, but they tend to be much more expensive. Lastly, your business success is greatly influenced by how well your software is capturing the highest and lowest energy prices in the day. An increase of only 1% in this accuracy will boost the success of your business. Now let's talk about some economics parameters. First, we have the tax credit and incentives. Next, we have different interest rates and market conditions. And lastly, only few consider the end of life of these batteries. It doesn't matter if these batteries will be useless in 10 years or 20 years. In the end, they need to be removed, and this process is very costly. This ties us back to our last slide. Different materials and technologies of the batteries may be recyclable, which will offset some of these removal costs. So we show the simple model and we show many parameters that are relevant to the battery storage facility. But with ChanceCalc, we can load zip libraries for much more complex models, as well as for any renewable energy project.